This has been and continues to be somewhat of a major dairy production area, and there's a lot of manure. Would it be possible with maybe 5,000 raspberry acres taking X million pounds or gallons of manure from the dairy industry, which is a lot of times just down the road in our community, and applying it on our acres, building our soils back, and relieving some of the pressure of the manure management for the dairy industry.
We have these two coinciding production systems that historically there's been land transfer, land rotation, and historically manure was applied to bearing red raspberries. But because of evolution and concern over food safety, that practice has essentially been eliminated. The big picture is to try to reduce the overall importation of nutrients into the county, because we have literally right next to each other is a source of nutrients and a sink that are disconnected because of those concerns. We took a look at this situation and opportunity and looked at it from a number of different perspectives, but one and first and foremost is that if we are going to utilize nutrients or biofertilizers derived from manure, that they have to easily replace what is typically relied on from a conventional. So looking at the agronomic efficacy of these various biofertilizers. Two is to look at the economics around that. How, can they be immediately replaceable? And then three is to focus on education and outreach regarding the problem as a whole, but also for results from the project itself.
The approach that we use is called the stated preference approach. And the basic idea is you ask people hypothetical questions about products or policies that don't yet exist. The basic idea for us in the DairytoBerry project is it allows us to ask about demand for manure-derived biofertilizers that maybe don't yet exist or exist in configurations that, or ask them about configurations that don't yet exist. We surveyed berry growers as well as some other crop growers and also crop consultants.
What came out of our initial meetings with growers was that there were three attributes we wanted to focus on. One was form, the form of the biofertilizer. The DAF solids, as they are produced, are about 70% or 75% moisture, so they're relatively wet. And we wanted to look at whether either doing an air drying process or a pelletizing process might make them more appealing to the end users. The other thing that we wanted to look at was method of distribution. There was some indication that it might be important that growers got this product from their existing fertilizer suppliers. So we included that as one of the attributes, and then the other attribute, of course, was cost. And basically we looked at cost as a percentage of current fertilizer costs for these growers.
So within the project, we looked at a number of different treatments. First and foremost is we looked at raw manure from a dairy farm. Secondly was anaerobically digested dairy manure. Third was DAF solids derived from dairy manure. Fourth was ammonium sulfate, also derived from dairy manure. Fifth was compost that in part came from dairy manure solids. And we added on two additional treatments. One was a conventional fertilizer check, and a last one which was an unfertilized treatment. And the idea again is to be able to compare those various treatments amongst each other. A little bit more specifically about the DAF treatment, that stands for dissolved air flotation, and that is utilized downline of an anaerobic digester in this case, and it is essentially additional solids pulled out of the liquid fraction that typically have a little bit higher concentration of phosphorus and potassium.
My main component of the study was to ask growers hypothetical questions about whether they would be willing to try a new manure-derived biofertilizer rather than their current status quo soil amendments. The the three key attributes that we had for this new biofertilizer, the most important one to an economist is the cost, the price. So we set three levels of price. One was sometimes you were asked about a biofertilizer that was the same cost as the one you're currently using, so 100% of cost. Sometimes you were asked about a configuration where it was half of the cost of your current soil amendment, or 50%. And then the third level of price was 75%. And we chose prices that were lower than the current soil amendment because we believe that because of risk aversion, because it's a new product, we would need to be able to subsidize probably the product to be able to get adoption. The second attribute was the form that the biofertilizer took. So one of the forms was a semi-wet form that had a higher moisture content. The other two were an air-dried form that was drier, and then one that was actually pelletized. And we actually gave people that did the survey some samples of the three different forms. And then the last attribute, we had heard from early focus groups that it might matter whether you could get this new biofertilizer through your existing distributor or whether you needed to get it through somebody that you didn't have a relationship with already. So again, each of those three attributes we changed in a very careful way across 6 different choices. As we expect, cost was a very important determinant of whether folks were willing to use a new biofertilizer. The distributor channel was not, but that people preferred air-dried and pelletized forms of the new biofertilizer.
My concern and really desire with pursuing the manure application was to see if it really was something that would be practical for a grower in our industry to do in terms of the availability, the transportation, the application, then figure out the cost of that, compare that with commercial fertilizer in terms of nutrient needs. I wanted to explore that.
In addition to the treatments themselves, we were shooting for targeted application rates of nitrogen, phosphorus, and potassium to meet commercial standards. And so we came up and added additional conventional fertilizers to meet so that each one of these treatments, with the exception of the check, the unfertilized check, had estimated equal parts of nitrogen, phosphorus, and potassium. For the purposes of this trial, we had a variety of different sources of nutrients, as I've already described. And those were either hand applied, because we're dealing with small plots, or they were applied with custom applicators, fertilizer applicators. In the case of conventional fertilizers, the industry standard. But additionally, our farmer cooperator had a custom-built manure spreader that places the manure just at the base of the raspberry row, such that nutrients were basically not applied between rows.
Given the situation in the industry over time, we're recognizing that production is not what it used to be. And if you really kind of plot that out, wow, that means in about 20 years, this isn't going to make sense at all. We need to shift some gears or change some things up in our systems. And so I personally started thinking that it had something to do with the soil condition and trying to understand what that might be to give some clues so I could connect some of the dots and hopefully come up with a solution.
So over the course of 3 years, we evaluated plant growth, looking at cane diameter, cane growth, yield, and yield quality, specifically looking at a variety of different specific yield quality indicators. And what we found is that there was no treatment effect for any of these indicators at any point over the course of 3 years. Soil health is really important for the red raspberry industry because of historical issues with land rotation. And as a result, we took a look at a variety of different indicators. And what we found is that for all of the treatments that we evaluated, which included the manure, both of the manures, the DAF solids, and the compost, we did not see any significant soil health benefit from a physical perspective, which included infiltration, compaction, and a lot of that probably was the result of the fact that these products were top dressed and not incorporated. And so we would expect to see that change to occur over a much longer time period than if those products were incorporated. As far as the performance and eventual impact that these had on crops, we'll start by looking at the impacts that it had on soil nutrient content. And what we can essentially say is for the most part, they acted synonymously with the conventional fertilizer treatment.
These are things that growers think about when they're adopting new fertilizers, and they want to know what the effect is going to be on their soil and how that's going to impact their crops.
Soil health is really important for the red raspberry industry because of historical issues with land rotation. And as a result, we took a look at a variety of different indicators. And what we found is that for all of the treatments that we evaluated, which included the manure, both of the manures, the DAF solids, and the compost, we did not see any significant soil health benefit from a physical perspective, which included infiltration, compaction, and a lot of that probably was the result of the fact that these products were top dressed and not incorporated. And so we would expect to see that change to occur over a much longer time period than if those products were incorporated. So taking a look at the bigger picture of this story and looking forward as to what the potential is for building this relationship, a stronger relationship between the dairy industry and the berry industry, there's several things that are of importance to discuss. First of all is the issue with storage and distribution of these products. And these would require new infrastructure potentially, and also new mechanisms of distribution, even if it's at just a county level. And currently there's the current agronomic suppliers have already invested a significant amount of money into infrastructure for storage and distribution. And so to sort of overcome that, there probably have to be some incentive programs to make that transition, because it's at this point in time, the growers are largely interested in just getting the nutrients that they need and less prioritize where they come from. And so that really is what would come from a supplier perspective.
Some of the questions that I or anyone might have is, so Randy, what at the end of the day, do you think this really makes sense? You're talking about on the cost side, or are you talking on the hassle side, or are you talking on the crop response side? There's a lot of factors, as people that are in agriculture understand very well. Certainly I like the change in my soil that I can physically see in terms of aggregation of the soil. The amount of worms that are present has changed considerably. And certainly that's not all from the manure application. I see it as the manure is another component of my soil building regime, is how I think about that. Agriculture is important. No matter what form we find it in our communities, I want every sector of that agriculture to thrive for as long as possible, because my experience in this community has been a lot of agriculture options. I want to maintain those for coming generations.